I'm Christian Howard.
I'm Varun Devsuku.
And we are Caelobotics Group. So this is a brief overview of our presentation. Law enforcement agencies are eager to adopt drones as assets, and there has been an increase in the use of drones, or SUAVs, small unmanned aerial vehicles, over the past few years. This trend is expected to continue.
There are several reasons for this, but the two most important ones are drones are easier to maneuver and deploy than patrol cars, and they provide a necessary bird's eye view of what's happening on the ground.
So, SUAVs enable law enforcement to make more informed and efficient decisions.
The problem, however, is these systems are risky to fly over people. They're restricted in range. This shot here shows the operational radius for most commercial drones. And we have a video which shows, which addresses increase in drone hacking over the years.
We're demonstrating the vulnerability of commercial drones. Not only can someone take control of the drone, but they can also crash it.
Now, part of the reason that drones are easy to hack is because they use a conventional open source radio protocol that has a high risk of interference. This chart shows the increase of accidents due to drone hacking. This number is now equal to the number of accidents due to device malfunction. And this data accounts for both intentional and unintentional interference.
These are the most significant problems which inhibit law enforcement agencies from deploying drones. The Caelobotics system strategically addresses these drawbacks, and we have created a drone which is safe to operate over people. It's capable of long-range flight and is operationally secure.
To go into more detail, our fixed-wing drone, which you can see right back there, it has longer range, it has an increased battery life, and is able to fly beyond visual line of sight.
Safety is a very important feature we have included in our drone. Our drone is capable of continuously monitoring itself. We have implemented sense and avoid technology, and we can fly our aircraft in restricted airspace and comply with manned air traffic.
So, we have designed a way to operate the Caelobotics system over cellular networks. And the safety of our system will be similar to that found on e-commerce sites.
And we're able to do this by implementing a 4-level security architecture where the operator's command is encrypted using a proprietary Mablin protocol. Our backend servers process and further encrypt the signals and forward them to a wireless carrier who have their own security measures in place. And finally, our aircraft's onboard firewalls has the ability to distinguish the right command from the wrong one.
The Caelobotics system is also an intelligent one, and the onboard flight algorithm creates flight paths away from population centers. It actively senses and avoids other aircrafts in the vicinity, and it adjusts its flight parameters to accommodate for changes in the environment.
And this is a screenshot of our ground control station. This is what we use to create a safe flight path for our aircrafts. And based on these unique advantages, by 2021, the Caelobotics drone will be the safest one on the market.
Now, you've seen our 3 value propositions. These also correspond to longer-term intellectual property rights that we are pursuing.
Some additional features of our aircraft include multi-system control, where one human operator can control more than one aircraft using a single ground station. And the Caelobotics system has been designed to carry a vast array of payloads.
So we have several partnerships. AUVSI sets the industrial standards for drone operation. We're partnering with them on their Trusted Operator Program, or TOP, to ensure that our pilots have the best training available. We're also working with AirMap to facilitate airspace management. And we're going to start with a single use case on college campuses. This is actually a screenshot of our system, which shows the aircraft's location. And we happen to be testing this right here in the Link Lab, so that's us right there.
This is the size of our market. These numbers show the annual spending on hardware and software every year. And we have a three-step market entry.
So first, we're planning on doing beta testing on university and college campuses. And with this, we're aiming for market penetration and data collection. We are planning to employ a subscription-based revenue model throughout. And the first few universities who implement our system will receive a discount on the system.
Through extensive customer discoveries, which include the Charlottesville Fire Department, we had an officer who told us that the drone technology is growing and a lot of departments want to use it, and they're actively pursuing it.
And our third step will be to expand to private security companies and to take our best use case scenario to the international market. And Drone Powered Solutions has done some research on this, and they have estimated that the addressable market of specifically drone powered solutions for the security industry is over $10 billion.
A lot of competitors are understanding that safety is a critical issue when it comes to drone design. And here is a chart. Here's a chart which shows our system and compares it to our competitors in the same weight and power class. And only the Caelobotics system is both operationally secure and has intelligent control.
So preliminary market data suggests that the list price for systems like ours is between $50,000 and $100,000 per unit. Now in the first scenario, our gross profit would be $31,000 per unit, sold at $50,000. And in the second scenario, our gross profit would be $74,000 per unit, sold at $100,000. We expect that our product will sell at a price somewhere between the two scenarios. So we spoke with several industry experts and concluded that we could reasonably capture at least 2% of the market within the next 4 years and 10% within the next 10 years. This places our expected revenue at $40 million by 2030.
Here's a roadmap of our future. We've already created a working prototype and launched our MVP. We plan on filing for IP rights and launching a public beta for university campuses by the end of summer. And by the end of the year, we also plan on hiring key people for marketing and product development and officially launch the police and fire departments.
With support from the Pike Fellowship, we went from just an idea to the purchase of equipment, attendance of the FAA conference, product design and development, to product testing, and to the successful flight of our system.
With additional Pike funds, we'll conduct more exhaustive customer interviews and identify industry-specific partners. We'll attend 2 key conferences. The most important one is the meeting of Virginia Association of Chiefs of Police, which will be held in Virginia Beach this summer. Implement proprietary secure mobile communication technologies, file for IP rights, and provide a proof of concept for safe operation of multiple aircrafts in a single airspace. This is a pie chart which shows percentage-wise breakdown of our projected expenses for the rest of the year. And this is our team.
I'm Christian Howard, a PhD candidate studying digital humanities.
I'm Varun Devsakil, a PhD student in computer science, and this is Rick Willa, a business mentor, who also happens to be a senior entrepreneur in residence at the UVA's iLab. And this is our company. Thank you.
That is exactly my thing, I think.